Hello everyone. The demonstration that we are going to show you today using the PowerPoint slides is the lab sessions of Tclp. And then these lab will be used to support the CSE432, solid and hazardous waste control. The material that we are treating today is the cathode ray tube, which is the conventional type of the monitor that we have been using for computers. When wasted, this type of product is considered hazardous to the environment as there are a lot of lead containing in different part of the materials. And then lead is a heavy metal, which is harmful to the environment and also the human health. This page shows the government arrangement or regulations regarding to the workflow to treat the CRT. And then you can see from the slide that there are a bunch of different kind of procedures, like including crushing and making into different kind of pieces and then putting into the acid. So the major component of the lab today is trying to reproduce or repeat this kind of what we call the Tclp procedure to remove the heavy metal from the waste. Before we start our lab, these sections introduce briefly about the lab safety, which is critical whenever you need to go to the facility.
Welcome to the Water and Waste Laboratories. I am Jonathan. Laboratory safety is very important in our laboratories, and I would like to remind you to take the following safety precautions. Firstly, please wear a laboratory coat to protect your skin and personal clothing. Secondly, please wear safety goggles and gloves while handling chemicals. Thirdly, please wear fully covered shoes to protect your feet. Fourthly, no eating or drinking is allowed in our laboratories. Please also read the safety guidelines before working in the laboratory. If you have any questions during the experiments, please do not hesitate to ask our technical staff. Thank you.
The major component of this experiment is to clarify whether our solid waste still contains heavy metal after the TCLP treatment. Meanwhile, a lot more details has been provided in the handouts. Please have a look. This is the material that we are going to do the test. And then you can see like it's a very big compartment, and then there are several sections. This is the screen, and I don't know whether you have been seeing this kind of screen at home or anywhere. And then this is the tube that in the end of that screen. And then before we do the experiments, we need to separate out the three compartments. So there's a protection covers in front of the whole CRT, and then you can look. It looks like this, and then there are a bunch of, you can see some coating over there, and then this is a part contains some quite a lot of the lead, and then you can see another compartment over here. So before we do the experiments, we need to separate all those things into pieces, and then use a hammer to crush it into the fine powders. And then so basically like you can see the powder from different compartment, and then it looks like with a lot of glasses. And then like in the normal case, the finer the particles, the better the ability of that heavy metal to dissolve in the treatment acid. So like in this case, we try to crush it as much as we can. and then you can see all different kind of samples. For each group of the experiments, you have different kind of samples, so that including 4 pieces, like the body, the front cover, the tube, and then some metal part of. Okay, this set of the slide demonstrate the preparation of the extraction fluid, and then regarding to the compositions of how to prepare the fluid is detailed in the handout. You can also take a look from those, which is including the recipe. And to take out the acid from the uh, our original bottle, we use a tubing, and then like you can control the ball to uh, withdraw the required amount of the acid, and then putting into uh, the bigger container. And then after that, you can put the distillation water in it for dilution. So like basically what you need to do is just gradually putting everything in it. Well, so this is from the screen. You can easily see how it goes. And then whenever you add enough, you gradually stop. So I'm not sure whether you have been working in the chemistry lab, and then this is very much typical to prepare this kind of samples. And then the uh, whole bottle is with uh, con consistent bottom. So like you just mix it well, then you got the liquid. Before we do the experiments, this page show you how the sample has been prepared, and then like how we crash, and then uh, screen or filter the particle size that we want. And then over here, because you know like the sample that we are handling is a toxic compound, uh, it's a little bit harmful, possibly if we don't handle it well to the technician. So like over here, we use just a simple uh, uh, like soil or mud to uh, demonstrate how it works. And then the metal particles, the compartment is the sheath. So like you have different kind of particle size. The usually on the top is the big particle, and then at the bottom will be the finer particles. So like uh, then after you crush it with the hammer, you can collect that. So this is how we got. This page show you how the experiment has been conducted, and then the whole process is pretty much straightforward. I think you can easily get the idea from taking a look of this video. So I'm not going through the details of everything. I just want to mention that the technician to carry out this demonstration is Mr. W.S. Lam, who is a very experienced uh, expert in PolyU and then also in our department. So like I strongly recommend that whenever you have a chance, that come back to the school, you can visit our lab, and then we'll more or less maybe talk with them, or like maybe take a look of all the system. And then well anyhow, you can see extraction solutions has been poured into the bottle, including the samples. And then what you need to do is just like to shake it and then mix it and then wait a while. That's it. This stage is also very straightforward, and then I think you can easily get the concept from the video without too much detail of my explanations. So basically what you need to do is just mix the samples into the rotary mixer, and then like the rotation rate will be 29 rpm, and then like you just carry out the mixing for a certain period of time. So like the detail how much time that you need to do will be you can check the handout. Okay, the total missing hours. Now we show you the answer, which is 18 hours. And then also, yeah, the whole procedure is very much straightforward as we mentioned. It's just you just take it out. Okay, after we mix all the samples, then we need to do is just to separate the liquid and then the solid. So supposedly the solid part is already heavy metal free. Okay, so and then the instrument that we separate the solid and liquid is using the device with the vacuum, and then we put the filter paper in the middle of the compartment, and then we fix everything together, and then we gradually pour the samples into the instruments. So this is how it works. So gradually the liquid will be vacant to the bottom part of the liquid. So we just collect the liquid for the metal analysis, and then you can see like we need to pour everything in it. Well, most likely what we need to do is to take the record of the overall concentrations. In this kind of case, we can calculate how much heavy metal is dissolved with the volume. We can calculate how much mass of the heavy metal we got. And then the next big step, what we are going to do is to just take out uh, the filter paper, and then as demonstrated here that okay, so the solid part we just take it away. So as we mentioned previously, these solid compartment supposed to be clean without heavy metal. But if there are some heavy metal, that means like the acid or Tclp procedure is not good enough. Then we need to develop something else. So this is also the major purpose for the whole experiments carried out today. And then after we separate the liquid, we can put the required amount of the sample into the small bottle. This is the device we call it AAS, used to determine or measure how much amount of heavy metal and then type of heavy metal that we are having in the liquid. And then you can see this part of compartment. There are a few different sensors which can detect different wavelength of the light coming from the instruments. And then this part of the device is with high temperature, and then what the major mechanisms is just to withdraw that liquid and then most likely burn it out at high temperature. And then you can see like uh, when uh, when the experiments carry out, there is a beam of light passing through that fire. You see the fire, and then transfer into the wavelength. And then by determining what kind of the color and then wavelength of the light going into the sensor and then the amount, the computer can record the concentration of the type and the amount, the concentration of the heavy metal, and then the type. So to understand what is going on with the acid washing procedure. So now we are putting our first sample to do the measurement, and then of course there are this kind of operation of the analytical tool need to have a good expert to operating it, and then these instruments also need a standard curve using the fixed amount or concentration of the metal to calibrate it. Okay, so I think like right now the whole measurement has been accomplished. Okay. Also, this is the preparation phase. So now the real sample is going in, so you can see the fire, and then okay, the measurement of the real sample start. So yeah, and then we are going to repeat that for a few times. So later on, a set of the experimental results will be given to you for further calculations. So there are small exercises that you need to accomplish in your lab report. Okay, so that's the basic procedure for heavy metal analysis. The final stage of the lab is just to measure the pH. Okay, so pH is pretty much straightforward, like using the pH probe. And then before you do the measurement, you will need to raise it, and then, well, just put the probe inside the sample and then read from the instruments. You can get your reading of how much pH you got. And then, well, before you use the pH, the probe need to be well calibrated. Basically, you will have two type of buffer, which fixed at this standard pH to help you to provide the standard curve. Okay, so now we finish all the experiments.